Chapter 14 in the lab manual is an introduction to electrical control of fluid power systems. Up to this point, all of our experiments utilized manually operated DCVs, but in industry they almost never use manual DCVs except for really simple machines. So we're going to look at some circuitry, and along the way, for some of you this will be a review of basic electrical principles. For others it'll be brand new, but there were no prerequisites for basic electricity coming into this course. Neither is this a replacement for basic electrical requirements. The purpose of this unit is to give you experience with electrical control systems for fluid power. The design of this unit is such that it's going to be based solely on experience and observation. There are no questions as you've seen in previous units. This is simply an experience of learning how to read ladder diagrams and apply them to fluid power circuits. These are some basic terms that we use in electricity that may be helpful as you go through this unit, especially if you run into a problem and you're trying to diagnose what that problem might be. The term normally open refers to contactors that are not touching, while normally closed are those that do touch. This determines whether or not electricity will move through the contactors. A control relay is an electromechanical device that uses magnetism to close or open contactors. The contacts themselves literally are metallic circular devices that come together for the purpose of completing a circuit. A coil refers to a part in a relay that generates magnetism that brings the contactors together or separates them. A series circuit is a circuit, a completed path for current to flow where electricity will move in one direction only, and if there's a break anywhere in the circuit, well, then power is cut off. A parallel circuit is a bypass circuit, like a flow control. The electricity has the ability to move around something. A solenoid is an electromechanical device that produces a linear force or motion. A ladder diagram is an electrical diagram that looks just like the rungs of a ladder, and they are read from top to bottom, from left to right. Numbers are used to show where connections are made, and emblems or symbols appear between the rungs to tell the reader where the power is going, how it will be controlled, and ultimately how the circuit operates. A ground refers to a path leading to an earth ground. An open refers to a break in a circuit. A short circuit refers to power being grounded unintentionally. Alternating current, which is also known as AC current, refers to electrical movement in two different directions. Direct current is electrical current flow in one direction and typically is referred to as DC current. Magnetism refers to the attraction of a metallic surface to a magnetized surface. A switch is a device like a DCV for turning on or turning off electrical current. A limit switch is a mechanically operated pair of contacts that can complete a path for current to flow or can serve as an input to create a command signal for something to occur within the electrical circuit. A transformer takes electrical current and either increases it or decreases it, while voltage is increased or decreased. Often we see that high voltage is reduced to a lower voltage for use, and that the current is increased. A digital voltmeter, also known as a digital meter, is the standard tool for diagnosing and checking electrical circuit problems. Our first experiment appears on page 161 and is a basic circuit to test the power supply, and on our equipment it's normally 24 volts. The meter, though, can be used to check other problems that may occur in the experiments. Misconnections are probably the most common. Down below is your ladder diagram. Along with some of the diagrams for a few of these experiments, we will also use pictorials like you see in the upper part of the screen. Pictorials, though, are not used in industry. Here they're a guide to try to get you to understand how to make these connections using the ladder diagram. So the idea is that you will use them side by side, and then once you get an idea of how to read a ladder diagram, you won't need the pictorials anymore. So looking at the ladder diagram, you'll notice L1 and L2. So L1 is recognized as the power supply or line power. L2 is your ground. In this case we're using DC, so that would be your grounding circuit. On the first rung, our first connection is made to 1 PB, which is a normally open push button switch. Second connection is made toward the solenoid, where we have a DCV that has 4 flow paths, 2 positions, and is pilot operated but solenoid controlled. So when solenoid A is energized, that solenoid energizes the pilot, and this causes the valve to shift. Now it only has 2 positions, so the normal position in the diagram is the one on the right where the spring is attached. So if you energize that solenoid, the other envelope will be the flow pattern, and then if the solenoid is de-energized, then you go back to the envelope that has the spring attached on it. So basically you push the button, the cylinder extends, you release the button, power is discontinued, the spring pushes the valve back to the normal position, and the cylinder retracts. This circuit appears on page 162. What we have are a pair of rungs in the ladder diagram with 2 push buttons that will energize a pair of solenoids individually. If you look at the fluid power schematic symbol for the DCV, this is a 3-position block center DCV that is pilot operated and solenoid controlled. So the way that this operates is you push 1 PB, solenoid A is energized, and the cylinder should extend. You release 1 PB, the cylinder stays extended because the center condition is blocked. If we push 2 PB, 2 PB energizes solenoid B, and that causes the envelope on the far right to be engaged, and then the cylinder will retract. The circuit for experiment 3 appears on page 163. It's extremely close to the one that you built on page 162, although you didn't actually build it. The difference is we've added a selector switch on your upper left hand corner and a light, a power indicator light, on the top right. So turning the selector switch to on provides power for the circuit. Whenever the selector switch is in the on position, the light will be lit. Power will be supplied to 1 and 2 PB, which, as in the previous circuit, causes the cylinder to extend and retract. circuit for experiment 4 appears on page 164. It makes use of a device called a control relay. A control relay is an electromechanical form of switch with contacts. They form logic functions, and often they can be used to open and close circuits that conduct a little bit more current than the controlling circuit. In this diagram, all we're going to do with it is we're going to use the control relay's contactors to energize solenoid A. So looking at the ladder diagram, when power is supplied to the circuit and 1 PB is pushed, power is supplied to the coil of the control relay, and the contacts, which are normally open, will be closed. Solenoid A will be energized and the cylinder will extend. When 1 PB is released, the power is removed from the circuit. When that happens, the spring in the DCV, which is in the diagram on the right, pushes the valve back to the normal position and the cylinder retracts.